Hello, Antonio and Huisang. And
Hey, hey Roy, good
hi,
morning.
hi. Hi,
Hey, Hussein.
hi, a long time no see, Antonio.
Yeah, it's been a while.
Uh, How's going for you?
Everything's good. I
Mhm.
switched jobs, so
Oh,
now
six jobs. Oh,
yeah,
hi, Rita.
I now work out of Ireland, so a bit far.
Oh,
So, yeah, it's afternoon for me.
what time is in there? What time is there?
It's 3 p.m.,
Oh, 3 p.m. Okay.
so it's a very good time. You guys have the tough one this time.
Right. Hi, Mita.
Good morning.
Good morning to
Oh, good, you're here. Okay, I'm sorry. I had a little trouble logging in. My computer was very confused.
yeah, thank you. Take your time.
So I think I'm in. Okay, I'm having trouble with my camera. I'm just going to leave it off because I think it was defaulting to the lap. I didn't see my other camera. Um, so yeah, why don't we get started? Let me pull the document out or get the document ready to share. And so do we have any opens before we jump in? If not, let's see. I'm sorry, I'm getting there. Okay. So I was just reviewing the document. Make sure I'm at the right place. So it looks like that Yogesh wants to start reviewing here. And I've added some things from the main fault management document I want to review here, and I don't know if it belongs in this doc, so but I'll show you what I added. But I think last time we were talking, we were saying, okay, when we decode this, you know, what do we call these things? And so we'll end up, you know, passing a binary CPER of whatever format is necessary to the analyzer, the CPU, I forget what we call it, the CPU, and it will decode it into JSON and then, you know, analyze it and send CPADs for any actions we want to take. And so I think what we're talking about here is what the JSON looks like and what we call it. So Owen added a bunch of suggestions. Let's, I guess, take a look.
And hey, Drew, this is Evan. I talked to Owen about this as he went through and added these, although I just got my Google Docs access back, so I actually haven't even reviewed these myself yet. So, yeah, these are Owen's suggestions from that schema we reviewed, I don't know, a few months back, just for kind of a short name for what to call it in there. But if we want to just step through them, that's fine with me.
Yeah, I think we should at least glance over it. It makes sense, the concept. Like the first one, I guess that's error date time is what he's thinking.
Yeah.
Yeah, I don't know. I might be a little bit inclined to spell out date time.
Yeah, that'd be fine too.
If that's not controversial. You know,
That makes it clear.
Since not everyone's a Python person.
Right.
So if that's okay with people, I'll accept that. Okay, the next one is interesting. So I don't know if I follow error correctable. It's really error severity, right? It might be correctable, it might be uncorrectable. Right, this is runtime error logging.
I think we defined it like that because that's I don't know, a more, I'm concerned error severity is a little more ambiguous, I guess. Error correctable is just, did the system handle and correct that error?
So it's kind of a yes or no thing?
Yeah, it'd be a binary.
Let me just think about this.
And Evan, what does error source mean in that sense?
Demand or patrol, I think.
Yeah.
Okay, but why are they not two different? This is two different attributes. I'm confused. This is one attribute or two attributes, or?
Well, in this case, two. And the way we kind of organized the table, like you notice the next one has a whole bunch of different attributes for memory error location. That'll get a whole bunch of different.
But there's no.
attributes in the schema.
Yeah, but there's no hierarchy. They're all at the same level, right? They're not interdependent or anything. They're just a list.
I think that's the way we set it up.
Well, these, and the thing about these is this is the error location.
Yeah.
Like, but
the hierarchy will be something like error type is the higher level, and then under it it's the type, which is UE or CE, and then the source, which is demand or patrol. And then same thing for memory error location. The next row, the hierarchy could be like memory error location is the upper level, and then underneath it is all the identifiers of that location.
Okay.
Okay,
Yeah.
makes sense.
I
Thanks.
guess what I would say here, though, is the thing that makes me a little uncomfortable is that I'm not entirely sold on having two classes of errors, but I'm trying to think. Okay, I think I know what's bothering me. We could get a log from like, could we ever get a log from a DIM where we're indicating that we've not just lost data, but we've also mismanaged an address? Because that's not uncorrected, that's fatal. So I'm a little nervous about saying errors are either correctable or not.
I
I
guess,
think
do we call that error type and define some different categories like that then, Drew? I guess
Well,
I've always thought of it as binary, but yeah, that's on that. Sorry, good
well,
point
like,
on that corner case.
well, and I guess so. So error severity, you know, it can be corrected, which just means ECC corrected it. It can be deferred, which is like poison generation, and we might recover from it. And it could be uncorrected, not deferred, which means you need to crash. And then it could be fatal, where you're not sure you're going to make forward progress. Like you need to just kill the system and have some management processors log things because the fabric may be wedged. And I see why this makes sense from a memory perspective, but from a memory controller perspective, a memory controller may see a particular error and decide that something's fatal, or that there is no recovery. This isn't safe to poison. And I don't want to hem us in here if I don't have to,
Right. Yeah, I think that makes sense to me, as long as we define what's in that. I guess my hesitation is that I know we have some definitions of error severity, and I would expect that everyone else has slightly different definitions. So as long as we, define what goes in there and why.
Okay. I think I wish Velos was here, but I believe that the UEFI spec defines the severities.
And Drew, I think in the hardware fault management we defined the severities. Where
We
are
did.
Yeah, there's a whole table on what the severity.
Yeah. Yeah, I agree. I was just trying. Let's see. Yeah, error severity. They have fatal, corrected, and informational, which isn't great, and other
recoverable as well, right?
Oh, and recoverable, yeah, and UEFI. Okay, that is okay. That's better. I think fatal is really two different categories, but for the purpose of an error log, it doesn't really matter too much. Because some uncorrected errors, the system can run, the OS can go down the crash path, and some errors the OS you can no longer, you could be deadlocked. The chip can no longer make forward progress, and you just have to log errors and reset. But that isn't as important for the error log. So, and we do have that case defined. Those split apart in the spec, like you said, Antonio, and the OCP spec. So I'm gonna make it severity.
So one thing, I don't know if it's correct or not, but like, I think in the CPAD, this same error type would be a different sort of like contents versus the CPER, which is what we're talking about right now. Because whether it's action required or action optional, that sort of thing seems to be more in the CPAD, right? Here,
No, it's also can be in the CPER too.
okay,
So the you can have an error, and so like if you look at the like for Intel, they do define them as action required or action optional as like an error severity. I think AMD has a similar table where they list that out as an error severity, and they show you a kind of a flow chart. And so sometimes software has to do something, and sometimes there's nothing software can do.
okay.
So, yeah, I'm glad you brought that up. But I do think that is a CPER thing too.
Okay.
So I'm just going to call it severity, and I'll indent this. Say defined in OCP. And it is, we do have a list of severities there. So like you said, Antonio. So if that's okay, I'd prefer that because oh gosh, I didn't realize what I was doing. Okay. Yeah, that's
Yeah, one quick question about the fatal and uncorrectable errors. So I felt a little bit ambiguous about how to define that some DOE error is fatal or not. So the UE means the recoverable, right?
well. I don't think that that you have to define it that way. It's more that the memory controller will decide based on what it sees and how it was using the data.
Okay, in that sense, I think that the CE and UE means the ECC engine output, which is detecting and cracking and with the hardware manner, but recoverable and fatal is the another level. So the
Oh well, just trying to think. I mean, you may not need to. So I guess what I would say is that we could put the severity in, and you could just say, was it correctable or not, and ignore the other severities if you don't need to use them. The thing that I'm just a little bit worried about is that sometimes the difference will be important to the CPU analyzer, between recoverable and UE and fatal. So it may be something that started out as a memory error that becomes something worse. And so we want the memory analyzer to analyze it, but as far as the system is concerned, we're in bad shape and need to die.
Yeah, but I think if I hear Roy correctly, what he's trying to determine is what severities he has as in the DRAM device then can comfortably communicate to CPU analyzer or memory controller rather, from where memory controller and SoC can create CPER with whatever CPER defined severity they deem appropriate. Is that how we should look at it?
yeah, right. So for the case of, for example, even though we found that EUE detected uncorrectable errors during the operation, sometimes it could be recoverable or fatal, or sometimes it could be fatal. I want a more clear definition of the CE and UE, and the recoverable or fatal.
Oh, I can explain that to so I see your confusion. So recoverable just means that poison was generated, but it doesn't mean the system can actually recover. Just for example, um, so recoverable means that the scope of the damage was known. It's this cache line, and the problem is sometimes the cache line belongs to an application, in which case the operating system can kill the application and continue running. In other cases, it might kill a VM that owned the cache line. But if that cache line was a critical OS data structure, even though the hardware marked it as potentially recoverable, the OS may not be able to live without that cache line. And so the OS may promote the error to fatal because it may just say, oh no, I don't understand memory anymore. That was an important data structure. Or it could say, I don't understand where my process table is anymore because that was my pointer to it. So, so this is purely from a hardware perspective: is might it be possible to recover? Did that help any, or was I talking?
Yeah, I understood what you are saying, but in the context of this table, there is no way to distinguish the recoverable and fatal from the C and UE.
Well, this is just an error log that's generated when we have a runtime error, and so.
So maybe the contention there is who is generating this log, this table, who is populating the error type that we are defining in this table? Which agent?
The memory controller. I mean,
A memory controller. Okay.
This is a runtime error log, right? And
so I think for the memory controller sees what happened at DRAM, and then it assigns this, which should be okay because I think Roy, it's not upon. So in bottom line is I think this table is not asking the DRAM or DIMM to do anything differently.
Yes, that's right.
Memory controller can decide what how to communicate this for CPER formation to whichever agent is creating a CPER, which could be your BIOS or BNC.
Well, what would happen is there'd be an error, and the memory controller would detect it, and then some entity will log that error and build a CPER, and hopefully put it out on the RAS API into the RAS API's queues. And when that happens, somewhere in that process, we will build this error log and assign the severity. And so I guess my point is, you're right. That was an excellent point, Yogesh. The memory doesn't have to do anything differently. And if you all, for the purpose of your analyzer, just want to say it was corrected or not corrected, that's fine. And we're not even asking you to make a judgment call on these other classes. But my point is, I could make let's just say I could make an imaginary memory controller where I store additional ECC data in a DIMM. I could have maybe the DIMMs be lockstepped and double wide, and I could decide that if my lockstep fails for some reason, I see that they got desynchronized and I've lost a transaction between them, that I'm turning a memory error into a fatal error. And that's okay. From the memory vendor's perspective, it doesn't matter how the memory controller was using the memory. It will just generate an error log saying, hey, this particular DIMM had an error. Here's where the ECC bits appeared to be wrong, like in this location, and then analyze what your DRAM is telling you. But you don't have to worry about it being fatal or deferred or recoverable.
So not at creation, but in the analyzer, when a CPER is received and it's saying it's recoverable, then they need to have comprehension for what it means in the context of memory analysis, right?
Oh, that's actually a really good point, Yogesh. And so the point is that if it's recoverable, then that is less severe than uncorrected and not recoverable. But I think that by default, most DCC errors are going to be corrected errors and recoverable errors. It's only if if the CPU vendor does something extraordinary.
Drew, not getting into the analysis outcome aspect of it, just comprehending the data that is received, and then I think it's just going to be like a simple mapping. For memory analyzer, this could still be mean CE or UE, and that is something that SoC and vendor and DRAM vendors will have to work together. Like if I'm sending you CPER with, say, recoverable, how would you treat it in your memory analyzer, what it means, and then give some recommendation back to CPU analyzer, which can further have some value add depending on whatever additional mechanisms may be available in that SoC to work around that kind of error. And that goes back as a CPAD. So there are like 3 layers there.
What are the 3 layers? There's the CPER, the analysis, and the CPAD.
Okay, so some fault event happened. DRAM or DIMM sent some signal that fault in their terminology, which is CEUE, to the memory controller. Memory controller said, okay, I know what it is, and says, okay, I'm going to mark it as a recoverable, and sends it to the whichever firmware is creating CPER. CPER is created. CPER is sent to via RAS API route to your data center control plane, where you have a CPU analyzer running, which has wrapped into it a DRAM vendor analyzer, right? Now, CPU analyzer gives that recoverable error indication to memory analyzer. Now, memory analyzer, if it does not understand what recoverable means, it needs to have a mapping to comprehend that and give its memory level recommendation to CPU analyzer. But CPU analyzer again can say, oh, I understand what I have to do with this kind of an error signals from memory vendor's perspective, because I have this additional platform mechanisms available. And my recommendation is not going to be a PPR at this point, but I'm going to do X instead. So those are the layers I'm talking about. Right?
Okay. And by the way, I just remember that as you were talking, you made me remember there was an informational severity too. So, and it may be.
Anthony typed in the chat window the CPER definition.
And like let's say we do a post-package repair. We want to send an informational CPER back saying that the post-package repair happened, and in the stream of errors. And so that is also kind of interesting severity to look at. And the beauty of that is, you had a whole bunch of, let's say you had a series of errors over time. The analyzer decided to do a post-package repair, sent the message back. The post-package repair eventually happens, and so then in the same stream of place we're getting all the errors, we see a thing saying, okay, PPR happened here in the stream.
No,
and
so Drew,
now those errors go away, hopefully.
Yeah, so Drew, my point that I'm really trying to make is when we are logging errors, we're not trying to kind of analyze or create that analyzer system. We're just making sure we covered the interface in terms of what the DRAM is going to communicate, and then catch it on the other side and communicate it further. So our interface in this error logging table should be comprehensive enough to capture everything, and then comprehended back at the controller level, and then from there onwards it goes like the path I discussed. And then at the final stage, CPAD is given to your control plane, and you might, as Microsoft, say, well, I understand this because I have experience in my workload can tolerate X, so I'm going to do something else instead. So there is that layer too, right?
Yeah,
So
yeah.
the
And,
point
and
being, we don't need to get into the solution space, like analyzing space, but try to understand, try to stick to comprehensiveness of capturing the types that are understood by the agents that are creating and catching those, right?
okay, I guess my point was just that this data is actually useful. To like to have the additional severities may be useful for, but doesn't necessarily require action on the part of the memory vendor.
Yeah, I'm also thinking about that. It's useful, but are we creating this table from generator's point of view, or the memory controller, which is the first receiver, or like everyone? Because that's where Roy is like asking, how can I actually send you informational or recoverable? Because I don't use those terms in my hardware right now.
No,
So
but the memory doesn't send ECC errors anyway, except for ECS data, right? The ECC is checked by the memory controller, and every memory controller is different. So
that's a valid point. But what I'm saying is, when we define error type here, I think maybe we need to peel it off further. That what the do we need to go one step back and make sure that what is asked of DRAM to be sent to memory controller is compliant with JEDEC? I mean, that's implied in my opinion. But I think what terms that we are using here are confusing. And Roy and Evan, I think you guys should speak up and focus on something.
but JEDEC doesn't really talk about error severities. Like,
Exactly my point, right? JEDEC doesn't talk about it, but we are talking about it here.
But we've
right?
kind of clearly said it's the memory controller that's generating these this rows, right? I mean, there's even a column there that says log source detection point.
Yeah, and the memory controller's behavior is not entirely defined by JEDEC.
Yeah. So then, Roy, it shouldn't affect you because you are not doing anything differently. It's memory
Well,
controller which will comprehend these error severities and create the CPAD.
well, but I can show you if I was writing an analyzer as a memory vendor that I might say there's an informational thing I care about, seeing that a CPAD was acted on, so that because then if I see errors after, let's say I decided to do a post package repair, and then I see the CPAD or I see the informational CPER saying, okay, the PPR was done. I might see additional errors after that and go, whoops, that didn't work. Now you should replace the part. And so, I can see that at least the three things are obvious to me as informational, CE, and then the others. But we're not saying you need to parse the fine details of each, but the memory controller will log them, and by having the extra fields, we can do things with them if we ever need to.
If we are thinking of informational as the informational CPER that contains, whether an action was done or not, that's not really memory controller generated log. Then that needs a separate row, right? Otherwise, informational means something else. Like if we are trying to make informational fit that the CPER that we've talked about previously, which just indicates whether a particular RAS action was effectuated, then that's not the memory controller that generates that log.
Yeah, but I don't think we should push this error record like this CPER to cover everything. Like there's ECS data we're not doing here, right? And we talked about sending time series of errors, not single errors. So there's
But
oh, you have ECS there. Oh, that'll be interesting to find the severity for ECS. But anyways, I'm what I'm worried is are we expecting that a single CPER will be all that's sent to the analyzer? because we talked about history, right? And
Yeah.
is this
No, no.
one error or is this multiple errors or
So
I
imagine you get a C, a C, a C, and you say, oh, it's a bad row. You do a post package, you say send a CPAD to do a post package repair. You get an informational thing back. And Amita, I don't know where it's up to the SOC designer to decide who generates that CPER that's informational. If I'm building an ARM processor and I was getting an IP from Cadence or Synopsys, it might have some smarts in it that it sends a CPAD to itself as part of a sub analyzer, and that that smart IP can generate the CPAD and send it up to a RAS API collector on the SoC. So I'm not presuming that. I'm just saying I don't want to limit that. And so I guess my point is, if we just pass error severity through as defined in our in 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 UEFI and in the OCP hardware requirements doc, we have the flexibility to do that. If we may not use it, or we may, but we can just, but at least we aren't blocking it, and that's what worried me about saying it's either corrected or uncorrected. Is it didn't leave any room for.
Yeah, I agree that it shouldn't be like a binary thing because there are other, possible values. The only thing is that I hope you're not like overloading this informational with something that's not spelt out here.
I'm just not I guess I'm not presuming how actions are driven in an SoC, because I know that a vertically integrated CPU vendor versus a person who's putting together an SoC from multiple companies' IP, they may approach things differently. And so I'm just not specifying anything. I'm leaving it vague, saying that this error log can contain all the severities potentially. It may never have all of them, but it might, and I'm just not presuming anything about the design of the chip.
Actually,
So
since we're talking about log source, and we should also, I mean, like as we're going through the rows, we should just make sure that's good as well, because
okay.
yeah, because like the previous table, uh, I don't think it's necessarily consistent.
Well, it's a boot time table too, so it's a little bit more straightforward.
Yeah, but primordial boot time stamp isn't generated by the memory controller. That's the fourth row.
Oh, absolutely, that's true. And the system memory configuration is only partially visible to the memory controller. The number of channels, each memory control a channel may have a different memory controller, for instance. So, and then some of these things like the PMIC history, the RCD, they're on SM bus, so they're not connected to the memory controller directly either. And
Yeah.
there's a lot of stuff on SM bus that may not be related to memory potentially. So I think what we're saying is some entity gathers the relevant memory data and sends it at boot time.
so do a quick question on that same line of thought. Like, I thought this was a single error because it has a timestamp, but you're saying this could be multiple
Oh,
errors and
this
some
is a
information.
this
The
is a
analyzer can get multiple records for analysis. Each one of these is a single record.
yeah, exactly. So this is a single error, but it can contain. So when I gather the error data, this is what we want to gather for a single error, but we get multiple of them for an analysis, just like Sean was saying.
Oh, okay. Okay. So for example, you're expecting, let's draw out the case that you just said, right? We have a system, several correctable errors. We do PPR, and then we have another correctable error in that same row. So the analyzer will get each CE with the corresponding timestamp, an informational message with the PPR that was done. It will
Yeah,
get an ECS for that day, for that row, or that bank, whatever. And it will get the final CE that triggered this time the call to the analyzer. So it'll get all of that information in the same burst to the analyzer.
Yeah, and so what we've talked about, I think I've got a picture. So if you bear with me on scrolling, oh, maybe it's not here. I thought I had a picture somewhere that showed. I'll slow down. Oh yeah. Okay. Um, let's see. Here we go. So what will happen is we get a single error out of and we parse the header. And let's just imagine I got an error. And I parse the header and go, oh, yeah, this is an Intel or AMD or something else analyzer. I'm going to send it to the right company's analyzer. But right before I do that, I'm going to say, well, I know that analyzer asked for X much data, X, this many days or something. And so what I do is I say, hey, do I have any previous logs? And it could include, this could be a fatal error, and I could have a bunch of previous corrected errors that I correlate to the fatal. It could be, just like you said, a corrected error and a bunch of corrected errors and an informational error saying a PPR was done, and then a new corrected error that kind of indicates the PPR didn't work. All of those will go to the analyzer. The analyzer starts by looking at the latest error. The newest error, oh, it's a corrected error. I wonder, let's go look back in the history of this and see the history of the, of what's happened on this machine in the last X days. Oh, look, I've had a PPR, I've had a bunch of other corrected errors, and they're in the same place. Time to replace the part. So what we're talking about now is one thing that flows through here, but it gets bundled up with the previous things to be sent to the analyzer. Does that help?
Yeah. Now I understand. But then I would suggest that we do clarify in that severity that informational it's equal to NA, not applicable for some cases. For example, ECS is, there's no severity for an ECS. Like, could be really bad or could be really, we don't care. But I think there's some type of logs that are how are you going to send the ECS? You're going to send an ECS for every error, right? Because you have this every 24 hours. So in theory, every error in the fleet will be accompanied by its last ECS
Yeah.
report. So is that a severity informational or a severity? It could be flagging a lot of errors and those in that bank, right?
Yeah.
But the same thing for the CPAD, right? It's you perform CPR, you perform PPR. Is it severity fatal if you fail and severity informational if you succeeded? I think we should just put a note that there's many,
I think it's
not necessary.
informational. Yeah, I think it's informational no matter what. It's like, hey, you asked for a CPAD, I couldn't, or you sent a CPAD saying do a PPR, I did it, but it failed. Um, or maybe for some reason I was unable to do it. But that's just informational. It's not a hardware error in the system. It's a RAS action, didn't work. And so but I think we can, I guess what I would say is maybe we need to have another discussion on, the analysis flow and go through some examples of how
But I fully agree with what you said. I just want to note there that says like there's other things other than errors that will get as informational, like the example of a CPAD, like the example of an ECS, because it's just a note, making sure that this doesn't come from the hardware, doesn't come from the memory controller. This is the category we are deciding to assign to other data that's important in the flow that doesn't come from the memory controller, but it's part of the history we need to analyze the error.
such as CPAD was received and acted upon. Is that okay?
Yep, perfect. That covers it.
Okay.
Thank you.
And I think we should probably go through that in a little bit more detail and clear up some of the like how do we use these and how might these work? And I'm happy to propose some ways, if you all want, that these may be used. I don't know that fatal is all that important for the memory vendors, but we do have fatal errors, and I might have and I might have a memory error that's logged in the course of something becoming fatal. So like maybe I have a bug in the hardware somewhere or a bug in firmware, and the uncorrected memory error causes me to hang, and it becomes fatal, but there was a memory error involved. So I still want to analyze that error and say, well, what failed in the memory? But I may have more than one bug to deal with. I may have a firmware or another other hardware bug to address, or hardware failure to address. So anyway, I hope that's not too confusing, but I think we'll pass this to the memory vendors, and the memory vendors will use whatever they need out of this. And it could be that you just say, I care about informational because I want to see CPADs are acted on. I care about corrected errors, and then you might just decide to lump all of these as, if it's not informational or it's not corrected, then I don't care. It's you consider it uncorrected, and maybe that's all you use in your analysis. I'm not presuming, but if I just say corrected and uncorrected, you don't have the shades of gray to look at, and I'm saying we'll give you the shades of gray, and you can decide what's black and what's white. You can draw that line wherever you need to.
Mhm.
Okay, then error source. Error source I think of as like which DIM or so. I guess I was going to say maybe maybe error. Like, is there another term we can use for source? Like error scrub type?
Isn't address there, like row column address or channel?
Well, right. Well, that's the
Bring
location,
channel
right?
columns.
And
Yeah.
and the error source here, I think,
Detection mechanism,
it was defended to be for demand scrub or patrol scrub.
like error detection mechanism. It's kind of wordy.
Yeah. How about a scrub type?
Yeah.
So Evan, is that okay with you if we say error scrub type?
Evan has dropped, but you can leave him a note comment there if you want to ask him.
Okay.
And using the same rationale you said before, can we put other? Demand error, patrol, or other, like ECS? I'm not saying you put ECS as a scrub type. I'm just saying, like, is there like a third option, or do we always have to be demand and patrol?
Okay, hold the thought. Just one second while I type. I'm trying to catch up. Like, okay. And so, sure, other. I mean, and there may be other techniques to use to define these errors. So, sure.
So is this just, it'll take no value in the case that you get just a standard corrected error or standard uncorrected error?
Well, in the case of a standard corrected error, that's a demand scrub. Is that what you're asking?
If that's what we're calling, isn't there also for like, say like some other memory types, there's a software initiated demand scrubs, like HBM. I think
Well,
that's it.
the HBM doesn't really demand scrub typically because it doesn't have a cycle to. The ECC is calculated inside the chip and can't write there's no cycle to write the correction back, so it just has basically a patrol scrub. Now, you at a higher level could say, oh, HBM sent me a uncorrected error. I'm going to go ahead and write the value back to it, and that would end up being a demand scrub. But the HBM doesn't have anything special there. It's mainly just patrol scrub and demand scrub if the people that designed the memory controller were really on top of things.
Yeah, but I think there's the feature I think Shen is referring to is address range scrubbing, where you preemptively clean up a sector of the memory to use it. So it's it's a patrol, but it's a focus
It's
patrol
triggered.
for a specific thing.
Oh, okay. Okay, I wasn't familiar with that. So then that could be a patrol scrub or other, right?
Okay.
I think. I mean, do we? I don't understand it well enough, but it seems like patrol to me. But
It's a patrol, but it's not a patrol that happens every 24 hours. It's something you issue a command to do a patrol or a particular area of your memory to clean that area for use, right?
okay. So that would be other, I guess.
I would put it on other. I wouldn't worry too much. It won't make a big difference for the analyzer, I hope.
Okay.
Roy, I hope that's not like an issue for the analyzer who found the error.
But, um,
Does it? I mean, Roy, is this enough for you?
yeah, I think that's enough, but I didn't see any other cases through the error log analysis. So for us, the demand and patrol scrub is enough.
Okay.
Um, uh, yeah,
Sounds good. So, okay. The memory error location. Let's see. Oh, that's interesting. Let's see. Socket ID, rank. Something. It looks like there are more items over here than over here. So I'm trying to bank group device subchannel. Okay, slot. Yeah, this is interesting because
You don't have host ID, it seems.
yeah. Well, what is? I guess here's what I don't understand is what is processor ID? I assume that's the socket.
That will be socket, I think, too.
So if it's okay with you, I'll just add host ID like that, and now they match. And are you all okay with the wording?
Can we just call
Oh,
it socket ID
rank.
or change the other side to processor ID? I mean, just to keep it obvious.
I think socket ID may be a little bit clearer because processor ID might be the processor serial number or might be the
Yeah.
processor's location.
right.
Yeah, socket ID
Socket
is
ID
Okay, ID is better.
And you may want to change the order of subchannel and rank. I think subchannel comes right after channel.
Oh, they're in different orders. Is that what you're saying?
In the command box, the last one, you can move the rank after subchannel. That would be.
Sure.
We don't have the slot, but do we need the slot for something?
called channel slot for some reason. I'm not
Channel
familiar with
slot
Oh,
the
ID.
yeah.
channel slot.
Channel slot ID.
Yes.
Why is it
Oh,
channel slot ID?
Oh, yeah, I see channel and channel slot. Okay, sorry, I didn't see that.
I think because the slot, it may I think this was actually something he did that's subtle and it's interesting. Good question, Mita. So when I think of slot ID, there are two ways to look at it. There's where am I on the channel, and that's kind of interesting because the thing furthest out on the channel might be the thing that terminates the channel, or have a different termination setting for signal integrity, and that's kind of interesting because the other way to look at slot ID is when I worked at HP, we had superdomes that had, I don't know, a ginormous number of memory slots in a particular blade. And those slots were labeled with like 1A, 1B or something. Yeah, they were still silk screened on the motherboard, and it may or may not have anything to do with the channel.
Oh, so you
And
mean dim slot then instead of.
well, but yeah, but I think this is interesting because see the chipset, the memory controller views the memory one way. They view it, they're usually numbered like 0 to something. And then, but the OEM will silkscreen something entirely differently on the labels. A lot of times they'll give clues like, oh, there'll be a DIMM 1A and 1B, and you must install 1A and 1B together as a pair. And then there's 2A and 2B, and so you have to put 2A, and so a lot of times these things get named in a way that forces you to install them, the parts a certain way. But what he called out here was what well, and this makes a lot of sense. The memory controller, the memory analyzer needs to know where on the slot it is and how to associate it with other things on the channel. So this is more like the chipset's view of the location for the DIMM, not the technician's view who's going out to replace a part.
Okay.
Did that help at all?
Yeah, I think you're differentiating between the physical DIMM slot ID, right?
Yeah.
Okay, yeah, that makes sense.
Yeah, because what you silk screen on the motherboard, print PC board may be completely different.
Yeah.
I think it's from a memory controller view. I'm trying to remember the terms we generally use is channel and DIMM, DIMM 1, DIMM 2 kind of thing. That's generally DIMMs per channel, right? And that's what slot is here. So, and so I don't know. I mean, yeah, that's probably okay, calling it slot or DIMM.
I guess my only point is that, like it would be a little bit weird to use the motherboard number. It would just make it unnecessarily complicated to use the motherboard silk screening here.
No, not suggesting that at all. Just,
Oh yeah, I know you are.
yeah.
I
Okay.
think we should, I do think we should put a comment. Remember, this is for all of us to agree on this. So I completely agree with what you just said, but I think we might forget in the future. So it's better to have a comment on
Yeah,
what we
so
meant for
next time
this.
around, we'll look at it, we just don't start
Yeah.
discussion again. We all
Yeah,
forget.
and Drew, I had another question around what you said. From a technician not being, this is not for the technician to change the DIMM. So by changing the host socket ID and host ID, we don't know if the CPU has changed, right? Like if I give you a history of what failed and you change the CPU from that particular socket, the analyzer wouldn't know. And same question for the DIMM. Where in here is the serial number for the DIMM to make sure we didn't move it? Or if we move it, that we are getting the right history?
We did talk about that. Just looking. So,
The DIMM inventory information in the table above.
oh,
It
so
has
it's boot time.
supplier, part number, and serial number.
Oh, but that's then for just the boot time.
Right.
Well, I guess if you hot
But
plug,
you're not going to swap it in without booting the system, right?
Okay. No, that makes sense. I mean, hot plugging it. There's no need to account for that. So, and boot time, you get what is your DIMM, and do you get the processor serial number to make sure that you change it or didn't?
we generally want that. But this is what we're doing here is focused more on memory.
Okay.
But
Is there any
I
impact?
completely agree with what you're saying, that we want the CPU. We want to know if the CPU changed. And in the RAS API discussions, we are talking about.
Yeah, I was going to say that we don't have to have that CPU ID as part of the memory log. There is additional platform level information that's going to be part of the.
Yeah, and well, in the RAS API, we're saying that any RAS
Platform
API
inventory at higher level, right?
any RAS API endpoint will have an identifier. So if you change it, we'll see it.
Yeah.
That's a good question, though. Okay,
top of the hour, want to stop here, this row? Leave a
Oh,
note.
gosh, time flies. Okay. I put something at the end, and you added this, so we need to make sure we review this. And then I put in a scenario. I copied it from the hardware fault management document. But what I wanted to show people is, you know, how we might have a failure and we might not see any errors because you wrote the right values. And I talk about polling and leaky bucket and rate limiting. And I walk through the scenario and compare the different strategies. And talk about we have a potential error storm, the seepers, and we generate a CPAD. So anyway, if you could please take a look at this and tell me if you want to review it. If you think it's a bad idea to put here, I can pull it out. I'm not hung up on it, but I thought it might be useful to walk through kind of one of the scenarios that we're talking about for, like, how does the flow work and how might analysis decide to do something, and then what happens afterwards. And it kind of relates to the discussion about CPADs and informational, and how do we look at the severity a little bit too.
Okay. Yeah, I think it's good.
Okay, thanks everyone. So I guess I'll talk to you in a couple weeks, if not sooner.
Cool.
Yeah, thank you.
Thanks,
Bye.
Thank
bye.
you.
Thank you all.
Bye.